This is the assignment for design of structure lab. So basically this is a tutorial subject. So in this class we will be discussed about combined footing, and after that you have to draw one combined footing. So first we need to know about the combined footing. What is combined footing? So basically a combined footing supports two or more columns in a row. The combined footings can be rectangular in shape if both the column carry equal loads, or can be trapezoidal if there is variation in the loads. Okay, so generally the columns which carry the maximum load, here the shape of the rectangular would be more. Okay, so generally they are constructed of a reinforced concrete. Now in the design of footings, the footing assumes to rigid and resting on homogeneous soil. So this is our assumption. Okay, so when the location of the center of gravity of column loads and the centroid of the footing should coincide. So if it is not coincide, in that case column will fail. Okay, now the maximum bending moment takes as the design value for the reinforced concrete footing and should be checked for maximum here and bond, etc. Okay, now there are different types of combined footing that we have discussed already. That combined footing can be a rectangular shape, or it can be your trapezoidal shape. Okay, so this shape of the combined footing will be decided upon based on the uh, type of loadings. Okay, and type of loadings which is implied on the columns which is supported by the footings. Now rectangular footing, now the rectangular combined footing are part of combined footings, and they have a rectangular shape. They are supporting two or more columns. Okay, these are used when having a rectangular shape and have to carry equal loads. So basically this is the shape of a rectangular footing. Okay, see the shape, this is a rectangular footing, and these are the column, and here load will be implied upon the footings, and you need to calculate the maximum bending moment which is imposed by the load which is implied on the columns. Okay, and as well as you need to find out about the bearing capacity of the soil, and based on that you need to design the depth and other consideration of the columns. So our next part is trapezoidal footing. Now this trapezoidal footing, this is used when it does not present an equal loads. Here load would be varying in nature. So when present unequal loads, then use trapezoidal combined footing. So they do not have to fix shape and sizes, and when they come unequal load from a structure, so they cannot make an equal rectangular footing. So basically in the combined in the trapezoidal shape, this shape is not pre-decided. So first you need to calculate the load, and based on the load you need to provide the footing in such a way that the load can easily disperse to the soil. So based on the load, that shape of the trapezoidal footing is decided upon. Now this is the condition for the combined footing, when combined footing has to be applied. So when two columns are closer together causing overlap of adjacent isolated footings. So suppose you need to provide two isolated footing, but the gap between these two isolated footing is very much narrow. So in that case you can go for the combined footing condition. Second one is where soil bearing capacity is low. So if the bearing capacity is low, in that case if you provide the combined footing, in that case what will happen, the base of the footing would be more, and it would be more stable than a isolated footing. Then the proximity of building a line or existing building or sewer adjacent to a building column. Suppose in some cases what happens, you need to construct a column, and that column is a particular isolated footing, or isolated footing is adjacent to a particular building or any sewer or other things. So in that case the uh, uh, that capacity of the footing will not be maximized and it would be hindrance. Okay, so therefore in that case also you can provide the combined footing. Now next one is design process of the combined footing. So in the design process we'll discuss this in our next class.